Hello and welcome. In the previous lecture, you checked the definition of the Kubernetes ReplicaSet for the REST API server. In this lab, you will create a highly available REST API server using Kubernetes ReplicaSet. Let's get started. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Launch your terminal and make sure you are at the Fibonacci sample/K8 directory. You should have one pod running the Fibonacci REST API server from the previous lab. Check that the pod is there using this command. If the pod is not there, create it with this command. Run this command to create the replica set and list the available pods right after. There are two pods being created. See the status container creating. Each pod's name starts with the replica set name Fibonacci-backend-rs. Then a random 5-character ID is appended to it to make the name unique. Check again after a few seconds and you will see that there is a total of 3 pods running. Now list the existing replica sets with this command. The replica set has the 3 pods it needs in a ready state. Why did the replica set create 2 pods only, although it has replicas 3? The replica set was able to identify the pod that was created using the YAML file backend-pod.yaml as one of its own, because it matched its labels. So, the replica set acquired that pod. To bring the number of replicas to 3, the replica set needed to create just 2 more pods. Issue the following command to get a list of all objects running on the Kubernetes cluster. A list of the available 3 pods, 2 services, and 1 replica set is returned. Use the kubectl describe command to learn more about the replica set. Note that the selector labels match the pod template labels, both having app equals Fibonacci and tier equals backend. Furthermore, note under the event section that the replica set created 2 pods successfully. Let's delete the replica set and see what happens to the pod named Fibonacci-backend-pod that we created even before creating the replica set. Run this command to delete the replica set and list the available pods right after. Deleting the replica set deleted the pod named Fibonacci-backend-pod2, although the replica set did not create it. This is expected because the replica set acquired the pod, since the pod's labels match the replica set's label selector. Check the pods in the cluster after a few seconds. They should be gone by now. Let's create the replica set again and check the pods. Run this command. See? This time, because there was no pods that match the replica set's selector, the replica set created 3 pods. Wait a few seconds for the pods to start, then list the available pods again. You should see 3 pods in a running state. Let's now try to scale up or down the replica set. Run the following command to scale the replica set up to 5 pods and list the pods immediately after that. 2 more pods are being created to bring the total number of replicas to 5 as instructed. Please note that although we used the ReplicaSet YAML file in the command, the contents of the file are not changed. View the file on your machine. It still has replicas 3. We have 5 pods in a running state now. Let's scale the replica set down to 3 replicas again, this time without referencing the ReplicaSet YAML file. Run the following command. Note that in this command we identify the replica set by its name. The replica set kept 3 pods and is terminating 2 pods. In a few seconds, list the available pods. You should only find 3. Let's do a progress check of the application at this point. In this lab, you have created a highly available REST API server using the Kubernetes ReplicaSet. The ReplicaSet maintains a stable count of 3 pods for your server. That's it for this lab. Thank you and see you in the next lecture.